So far in our study of simultaneous equations, we have seen that in some instances we need to add our pair of simultaneous equations to eliminate one of our two variables, and in some instances we need to subtract our pair of simultaneous equations in order to eliminate one of the variables. Now the key question is, when do we add and when do we subtract, and how do we know if we're faced with a mixture of questions? So what we're going to start off by doing is looking at two different examples. So we've got two sets of simultaneous equations. Set A, we have 4x plus 3y equals 11 and 2x plus 3y equals 7. Set B, we have 3x plus 2y equals 7 and 5x minus 2y equals 17. Now in one of these sets, we have to add the equations to eliminate a variable, and in the other one, we have to subtract. If we get this wrong, we're not going to be able to solve the equation. So have a think, write down both sets, and see if you can work out which is the pair that we have to add and which is the pair that we have to subtract. Pause the video if necessary so you can think about this. Now, what you will hopefully see is that in the set of questions on the left-hand side, set A, you have to subtract the pair of equations in order to eliminate the variable. In the pair on the right-hand side, pair B, you have to add the pair of equations in order to eliminate the variable. Let's take a look at the pair on the left-hand side. Now, when we subtract, let's start with 4x take away 2x, that gives us 2x, and then because we have positive 3y and we're subtracting positive 3y, the y term is eliminated. So we're only left with x on the left-hand side, and then on the right-hand side, 11 take away 7 gives us 4, and we're left with a simple equation, 2x equals 4, generated by doing equation 1 take away equation 2. Now, dividing by 2 gives us x equals 2, and of course we then have to find out what the value of y is, and we can do that by substituting into either equation 1 or equation 2. So I'm going to substitute into equation 1. It doesn't really matter. Now equation 1 tells me I have 4x plus 3y equals 11. So I'm going to replace x with its value of 2. So that's 4 times 2 plus 3y equals 11, or 8 plus 3y equals 11, and then I have a very simple equation to solve. Subtract the 8, so 3y is equal to 3, divide by 3, and then y is equal to 1. And then just to clarify, my answers are x equals 2 and y equals 1. Now, how do I know that I have to subtract? It's because I have a positive 3y and a positive 3y, and if I were to try and add those two equations together, you can see me try to do this at the bottom here. If we did equation 1 add equation 2, then, well, 4x plus 2x would give me 6x, 3y plus 3y would give me 6y, and then 11 plus 7 would give me 18. So you can see nothing has been eliminated if I add. So adding is clearly the wrong option here. But for the pair of equations on the right-hand side, pair B, adding is exactly the right process here. Let's take a look at what happens when we add this pair together. 3x add 5x gives us 8x. Now here I've got plus 2y add a minus 2y, and they then cancel because I've got a plus and a minus. I'm adding them together, and that results in cancellation of y, or elimination of y. I then have 8x equals, and on the right hand side, when I add 7 and 17, I get 24, and I can simply divide by 8 to give me x equals 3. I can then substitute into either equation. I'm choosing equation 1 because it doesn't contain a negative, and so will probably involve a little bit less work. That's 3x plus 2y equals 7. And I've got to make sure I replace x with its value, which is 3. So that's going to give me 3 times 3 plus 2y equals 7. So that's 9 plus 2y equals 7. Subtract the 9 from this simple equation involving only y, so 2y equals negative 2, and divide by 2, giving me y equals negative 1. Now again, we can try and see what would happen if we tried to subtract rather than add. So the two answers we got here, x equals 3 and y equals negative 1, we would not have been able to get those answers if we had actually done a subtraction. So if I try equation 1 subtract equation 2, well, 3x take away 5x gives me negative 2x. I then have to do 2y subtract minus 2y, which would give me plus 4y. And then 7 take away 17 would give me negative 10. So again, neither x nor y would be eliminated if we subtracted. So it doesn't work. So in this example, subtraction doesn't work and we have to add. So the crucial thing here is to make sure we understand the difference between situations where we have to add and situations where we have to subtract. Now here, in this scenario, because we have the same number of y terms and they're both of the same sign, plus 3y and plus 3y, we subtract. Now over here, because the y terms are opposite, we add, because plus 2y add a minus 2y, that then causes our elimination of y. Now it's not enough just to have opposite signs or the same sign, we also have to ensure that we have the same value. So you can see here it's a 3y and a 3y and they're both positive, so that's when you subtract, and over here it's a positive 2y and a negative 2y, so you get the same number but opposite signs, and therefore the addition works. Now we're going to look at one last example and see whether we can work out what to do here. 6x minus 3y equals 12, that's equation 1. 4x minus 3y equals 2, that's equation 2. Now you can see we have in both instances 3y, and in both cases it's minus 3y, so we have the same sign. Now, what did we think about last time? Well, we said that we had to subtract if we had the same sign. So our question here is, what happens when we do this? So 6x subtract 4x, that's easy. We're going to get a 2x value from there. And then what happens over here when we have minus 3y minus 3y? Let's write it out separately. Minus 3y minus 3y. So our two minuses here become a plus. So it's minus 3y plus 3y, which of course gives us 0. So y definitely cancels out, or y is eliminated, which leaves us on the right hand side with 10, and you can then solve the rest of this equation. Dividing by 2, x is equal to 5, and we can then substitute that into either equation. I'm going to substitute into equation 1, which of course is 6x minus 3y equals 12. Let's replace x with its value of 5. So that's 6 multiplied by 5. Subtract 3y equals 12. That's 30 minus 3y equals 12. We can subtract 30 from both sides. So minus 3y is equal to negative 18. And then sometimes people like to use the trick where they multiply by negative 1. So 3y is equal to 18. And then divide by 3 to give you y equals 6. So there's the other part of the answer. X equals 5 and y equals 6. Now, how do we know that we've got to subtract? Well, think about the fact that we have the same sign and the same number in front of y. Okay, so we have minus 3y and minus 3y. So we have exactly the same y term. We don't have the opposite signs here. Now, what would have happened if you had tried to add these together? Well, you could have tried, but you wouldn't have eliminated the y variable, or in fact the x variable. So let's suppose we wrote this out again. 6x minus 3y equals 12. 4x minus 3y equals 2. And let's imagine we had added these together. Then 6x plus 4x would give us 10x. And then negative 3y, add another negative 3y, would simply give us negative 6y. Think about negative 3, add negative 3. It just comes to a value of negative 6. And then on the right-hand side, 12 plus 2 gives us 14. So nothing is eliminated if we do it this way, which is the wrong way. So make this very, very clear here. This example that I've written out at the end, that's actually wrong. So you cannot add them together. You've got to subtract.